zoom range, we want to move it faster. Now let's start taking care of the rotations. So let's go here and create a new function. Function camera, and this is going to control the base rotations. So base rotates, and it's also going to use the delta, and it does not return nothing, so void. And we're going to ask if we can rotate the base of the camera. So we're going to say camera can rotate base. This will be a boolean, by default true. So we can ask here if we cannot rotate the base, we return and skip the function. So if we can rotate the camera, then we want it to rotate. So we're going to create a new rotate function. So let's create a new function here to rotate the camera, and we want it to rotate left and right. So it's going to rotate the base. So camera base rotate left and right. It's going to need the delta, and we also need a direction to rotate. So let's call it dir and give it as a float. The function returns nothing, so it's a void. And here we want to set the rotation of the base of the camera. And if you remember, because this script is attached to the camera base, if we say here rotation, we are grabbing the rotation of the camera base, which is what we want. And we want to rotate the camera base like so. And that is the y coordinates of the rotation. So we want to go here and say rotation y. It's going to be added. That direction we set as argument, multiplied by delta, and it's also going to be added by the rotation of our camera rotation speed, which I think we're going to need to create. I don't think I added. Yep. So let's create a rotation speed here. Let's create a new camera rotate, and let's add here an export range. Just going to start at 0, and I'm going to give you a low value here. It's going to end at 10, then it's going to be stepped by 0.1, and its name is going to be camera rotation speed. It's a float, and its default value is going to be 0.20. Now that we have our camera rotation speed, we can go back here, camera rotation speed. Now we have a function that rotates the camera base left or right. And here it bends the camera automatically based on screen margins. There we go. So we are going to rotate the base of the camera. Here on camera base rotate left or right. Here we pass the delta, and here we need to set up a direction for our camera. So let's separate the direction of the rotation as a variable. So let's, just like the zoom operation we did, camera rotation direction is going to be a float and equals 0. So on here, we can just give the camera rotation direction. And this code should work. Now we are going to call this code to update the directions on the process here. And pass it the delta function. And on handle here, we can add if event is action camera. Oh yeah, we did not add it. So let's add here on the input map. Let's add camera rotate right and camera rotate left. And for the right, I'm going to give it E. And for the left, I'm going to give Q. So it's going to rotate the camera left when I press Q and right when I press E. So here we can say it. Camera rotate right. The camera rotates direction. It's going to be, and let's see which side now. So if the camera presses E, I want to rotate the camera negatively. Okay. So -1. And if event is action, and here we can put it rotate left. The camera rotation direction can be positive, so 1. And I think this could be an integer. It doesn't need to be a float. It could be an integer. Also the zoom direction. No, the zoom direction is dampened, so only the camera rotation direction works. So I think this should work. We handle the input, call the camera, and the camera here is changed on the process. We call an update. For the camera rotate, we rotate based on the rotating direction. So let's see if that works. And as you can see, it works pretty well. Now it's definitely slow. So let's fix this. Let's go here on the camera rotation speed. And let's add a new variable to control the camera rotation, the base. So we can separate the behaviors. So start at 0, ends at 20. And let's give the step of 1. So camera rotation speed. Camera rotation. Let's put camera base rotation. Floats and equals 20. So now we can go back here to our function camera base rotate. And here we want to add the speed of rotating the base. Now this should work a little more fast. Oh, and it's way too fast. So let's reduce this to, let's say, 12. Let's see if that works. Still too fast for my taste. Maybe 8. No, a little lower. 6. 6 is fine. Yeah. Now the code works, but we have a problem. The rotation doesn't stop. So what we're going to do to fix this is create a variable to control that rotation. So let's go here to var camera can rotate base. Let's type in. So this is going to be an internal flag. So internal flag. So we're going to use this internally. So the camera is rotating base. And the idea with this is on the unhandled input, if we rotate left or right, we'll say that the camera is rotating the base. But if we release any of those actions, which is the camera rotate left, or the event, this action release right, we want to say that camera rotating equals false. And now we can check this here. If we are not on the rotation base, where's the code? Here. If we cannot rotate the base, or the camera is not rotating the base, then return. So it's going to skip the function. And this is going to prevent us from continue rotation. And it doesn't work. Why it doesn't work? Let's see. The camera is rotating base here. Works. Maybe if we change this as... Let's try to say here is pressed. Yeah. So what is happening is because is action is a continuous check to see if it's pressed. And is action pressed is going to actually check when you press it. And it's going to check, and this is going to be valid one time only. And it's not going to call it back. So that is why it works. And it's almost the opposite of is action released. So now we have the rotation working as it should. And now it's a little slow. So let's increase the speed back to something like 10. Yeah, now it's better. So you can see that just by having these controls, you already kind of have an RTS camera here. I have the zoom function, which I think the minimum zoom function in this case can be a little lower. So the zoom in can be something low, like 4. Yeah, so we can get much closer to our units. And we can rotate the camera, zoom in and out, and you can do this under multiple times. And if you rotate the camera, it works because we are using translation. It also is automatic panning. Because of the zoom factor, power speeds are different. So yeah, and actually it's too slow on the zoom factor. So let's go to the automatic pan here, the function, and the zoom factor is multiplied by 0 here. So what we can do is offset this value. So yeah, it's because of the camera zoom. So rather than change this, I guess you can change this guy here. Yeah, so it's going to turn, yeah, but it's a lot faster on this one, but that's alright. As you can see, it works quite well. Now I think it's time for us to add the rotation by mouse. So if you notice, we only can rotate right and left. We cannot rotate up and down, which is the next thing on our list. And we're going to use the mouse input for that. So let's create a new function. And I think we actually need a couple of vars here. So let's add a camera can rotate. Now is the socket X. So now we are checking if we can rotate the X of the socket. So we want to control now the rotation. I think the camera is already rotated here. We want to rotate the camera like so. So let us go back here. And I'm going to use this on our next function. Import vehicles, which is going to be function camera socket rotate X, which is going to use the delta, which is a float, and we're also going to need a value. So let's put in a direction, just like the other rotation function. And first thing we're going to ask if we can rotate the socket. And if we can't, we should skip the function. Now we also need, just like the other code, we're going to need a new rotation, and which is going to be a float. Let's gather first it as the camera socket current rotation. So rotation, rotation X. So we are going to start by grabbing first the camera rotation of the socket. Then we're going to say new rotation. It's going to be subtracted by the direction plus multiply by delta multiply by our camera rotation speed. And the new rotation also needs to be clamped. So we need to limit the rotation. So let's do clamp. Then the variable being clamped is the new rotation. And here we need some min and max values. So let's go up here on the rotation codes and let's add a new variables here. So export range is going to start at 0 and let's say 10 and be stepped by 1. The name is going to be camera socket rotation, and we're going to say x min. And here we have to test it, because remember that rotation values are different. So here you're seeing minus 45, but this is not as a float. This is a degree, and we have to convert it. But we don't necessarily need it. I think you can do it the raw way. But it's going to be a small number. So let's try this. Let me duplicate this and add here as max, and we're going to put minus 120. And now we have our clamp values. So let's go to there and let's say here camera rotation, socket rotation. This is, which value is this? Okay, that is the min, and I want this to be the max. So we are giving the new rotation and clamping its value. Now we finally only need to add our camera socket rotation x to this new value, which is the new rotation x. And now we need to call this function when we want to rotate the camera. So this function rotates the camera, the socket camera, the socket of the camera. Now we need to actually call this function. So now we need a mouse rotation code so we can detect the rotations from the mouse based on the mouse offsets. So let's create a new function, which is going to be camera rotations rotates. Let's say rotate to mouse offsets. So I don't know if you ever play those RTSs that you press the right mouse and you can rotate the camera based on the offset. So that is exactly what I'm going to do now. So it's a delta float, and this function doesn't return nothing, so it's void. So this function is going to rotate the camera based on the mouse offsets, and is the camera socket. And it's going to rotate right and left and up and down on the X value. So right and left is going to be the camera base, and up and down is going to be the camera socket. So let's start by checking if we can rotate. So as all of the functions, let's create a new flag here. If the camera can rotate by mouse offset. And we can add this. If we cannot rotate, then skip function. Now what we can do is first thing, grab the offset of the mouse. So let's type var mouse offset, which is going to be a vector 2. It's equal to get viewports, get mouse position. Now this only returns the mouse position, so we need to compare it to a previous mouse position. So for that, we are going to need a mouse last position, and I don't think I ever added one of those. And this is going to be an internal flag as well. So you're going to need a mouse last position saved to be always saved as a vector 2. And this is going to start as 0. And we're going to record this on the on handle, I think. And we're going to activate this mouse last position when we press the rotation. And we're going to check and we're going to record the mouse last position every time we start rotating using the mouse. So let's add the input, which is going to be camera rotate mouse. I guess I can leave it only as camera rotate. And here I want to enable the right mouse button to be the input of that action. So here on the non-handle input, now we can check for that. And we just separate this. If event is action pressed, camera rotate, then we know we should start recording the mouse. So mouse last position equals get viewports, get mouse position. So now the last mouse position is recorded whenever we start to click. And we also should create an internal flag that is also saying as well. Just like the camera's rotating base, we can say camera is rotating mouse. And it's actually false. And here as well is false. This is an internal flag. So on the code we were doing, so here when we are pressing the camera rotate, we should say camera is rotating mouse equals true. And if you release that action, so it's action release, camera rotates, then we are no longer moving by mouse. Camera is rotating mouse equals false. So now we have an activator for our camera rotate and is actually recording the last mouse position. Now then we can check this code right here. On the process we can call the camera socket rotates. No, it's the camera rotates to mouse offsets. And we can add it here as well. If the camera can rotate to the mouse offsets, or if it's not rotating to the mouse, then we can skip it. Otherwise, we can continue. And here we grab the mouse vector. So now we can go here and start calculating the offset. Let's use the mouse offset here. And we're going to say it's equal to the current mouse position, which is our mouse offset, minus our mouse last position. So now we are actually having our mouse offset. And now we can rotate the cameras based on that. So we can say that the mouse last position, now it is, and now we can rotate our camera. So camera, rotate, base rotation, base rotates, left or right, give it a delta, and now we pass the offset. And the X value, so we only rotate left and right. And we can pass now the rotation to the socket rotation, which uses the delta and direction. It's going to use the mouse offset Y. Now let's test this if it works. This should be present at the process, which is, let's see if this works. So when I press right mouse click, it should start rotating. And as you can see, something is happening. It is rotating, but it's rotating like crazy. Why is that? Well, because we need now to update the last mouse position. Otherwise, we're going to spin to infinity. So So we can go here and type it, update the last mouse position to be the new viewport mouse position. So we need to get the viewport and get the mouse position again. Now the last mouse position is updated throughout the rotation, and this should stop that crazy spinning. And as you can see, it works. But now we have an issue. It's only rotate left and right. It's not rotated up or down. So we seem to have an issue with the X rotation values. So let's first try to disable the clamp limits, so we can see if that is the issue. So let's duplicate this, and I'm going to comment the line I have as a backup. I'm going to remove the clamp values. So the camera socket rotation min max. Now this should allow us to rotate up and down, but with no limits. So we actually know that the issue was the rotation, the limits here. So now we have identified the bug. Now let's see how we can fix it. And I'm going to fix by testing the socket rotations here. So let's put, let's give a big value. So let's do -10 and 210. Like so. Let's see if this works. Okay, so it definitely works. So now let's reduce the values here. Let's put it to 1. And here puts to 1.2. Let's see how that behaves. Okay. We are almost there. The max rotation here is too much. Let's see if this works. Okay. This seems a reasonable value. So it's not going to allow us to get perpendicular to the ground, but it gives a nice angle. I think this is okay. It's not super flat, and yeah, this is nice. Now, as you noticed, we now have a camera rotation thing. It works with the right mouse click. So let me just disable here the full screen, so we can actually test it here. And as you can see, you now have an RTS, all capable controls of the camera. We can rotate the camera right and left. We can rotate up and down, and we can also pan the camera. And there's also an automatic pan, which is working right here. So this is actually pretty nice. You now have a workable RTS controlled cameras. And all of those codes that we set, those numeric values, you can fix it and change it to pretty much anything that you want. So any of those speeds or angles that you don't like, you can change to your liking. You just need to update the script codes. So I think this is pretty nice. So that ends our tutorial. Thank you for watching, and I see you on the next video.